Alright, so for, oops, it's not number 1, it's number 16. So let me fix that. For number 16, they want you guys to get the inverse of g of x. So first thing, replace the g of x with y. That's step 1. And then switch the x and the y. So on the left side we have x. On the right side we have y plus 5 divided by 5y minus 6. And then third step is solve for y. So in order to solve for y, I want to get rid of the denominator by multiplying both sides by 5y minus 6. So same thing, and it's going to be squeezed in on this side, but I'll fix it on the, it'll look better on the next step, times x. So on the right side, this over this is 1. And so you distribute on the left side. So the left side is 5y minus 6 times x. So you get 5xy minus 6x. The right side is y plus 5. Now in order to solve for y, notice how you have a y on this side and a y on this side. You have to get them to the same side. And then go from there. So I'm going to subtract y from both sides and add 6x to both sides. By doing that, this becomes 0, this becomes 0, and then you have 5xy minus y equals 6x plus 5. So you can't combine these two because they're not like terms. So all I can do now is factor out the y, like this. And now I can divide both sides by 5x minus 1 to leave y by itself, to isolate it. So I'm going to divide. And now this is 1. Y is now by itself. And step 4, the very last thing, is go back to function notation. So it'd be g inverse of x equals 6x plus 5 over 5x minus 1. And that would be the inverse of the original function. Okay, so for 17, you're writing f of x equals x cubed, a transformation of that function, which shows that it moved 2 units up, 4 units right, and reflected over the x-axis. So for 2 units up, that would be k equals 2. For 4 units right, that would be h equals 4. And for reflection across the x-axis, that would be negative 1. So it would look like this. H is 4, so it would go in parentheses. Oops, that's a 3. Plus 2. And that would be it. So it's asking you for 18 to state the intervals where the function is increasing, decreasing, or constant. So if you look at the graph, it's increasing from negative infinity to 0. If you go across from left to right, from negative infinity to 0. And we always write these as open intervals. And then from 0 to 1, it's decreasing. See how it's going down? So from 0 to 1, it's decreasing. And then from 1 to 3, it's also decreasing. But it's a parabola shape on the right side. If you go from 1 to 3, it's also decreasing. It's going down. And then from 3 to infinity, the graph starts going back up. And at no point is it constant, so there's no constant for this particular one. Okay, so this cubic function has reference points -1, -1, 0, 0, and 1, 1. A is -1/2, K is -5. So remember, A and K affect the Y only. So the X is going to stay the same. So when you transform the points, you get -1, and then -1 times -1/2 is 1/2, minus 5 is -4.5. And then 0, -5, and then 1, -1/2, minus 5 is -5.5. Alright, so now we're going to plot the points. -1, -4.5, about here. 0, -5, and 1, -5.5, about here. So remember, the shape of this is something like this, and like this. Okay, so here's another cubic function. This time h is -4 and k is 3. So you see here in red how it's going to affect the original reference points, x minus 4 and then y plus 3. So that's going to give you -1 minus 4, and then 1 plus 3, then -4, 3, and 1 minus 4, and 1 plus 3. Oops, I just realized it's a mistake. So here, this is a negative. So it would be 3 minus 1, 2. So this one right here, let me just erase it. It's probably easier. Is 2. So here's the graph. So we have -5, 2, -4, 3, and -3, 4. So it looks like they're lined up in a line, right? I mean, they are lined up in a line, the 3 points, but it's not a line. A cubic function, just like number 19, is a curve. Goes like this. So here I showed the transformations. So the x is affected by the h and the y is affected by the a. Okay, so now we're going to graph these 3 points. So -5, -3, -4, 0, and -3, 3. Again, they're lined up in a line, but this graph is not a graph of a line. It's a cubic function, and it goes like this. Now, it's not as curvy because of the A being so big. It just stretched it vertically, but it's still a curve. So for 22, the h is 3, so that affects the x. So it's going to be x plus 3. The a is -2 and the k is +2. So those two affect the y. So -2y plus 2. So now we're going to transform these points. And -1 plus 3 is 2. -2 times 1 is -2 plus 2 is 0. 0 plus 3. And -2 times 0 plus 2. And then 3 plus 1. And -2 plus 2 is 0. So remember, the absolute value function is a V shape. So 2, 0, 3, 2, and 4, 0. Like this, and like this. Alright, so for 23, what I did was I factored out a negative from the radicand, so that I have it set up like this. So from here I know that the x is going to be multiplied by -1, and then the h is 3. Okay, and k is -1. So when you do the reference points for a square root function, they are 0, 0, 1, 1, 4, 2. And then that means that, let me see, x is going to be multiplied by negative 1, so negative x plus 3. Y is minus 1. So when you do the transformations, you get negative 0, which is 0, plus 3, 0 minus 1. Then negative 1 plus 3 is 2. 1 minus 1 is 0. And then negative 4 plus 3 is negative 1. 2 minus 1 is 1. Now we're going to plot them. So on 23, you plot 3, negative 1, 2, 0, and negative 1, 1. And the shape of that is, oops, didn't move it. Okay, there it is. It only has one arrow, the one here pointing to the left. This here at 3, negative 1 is a dot. Okay. Alright, so for 24, A is not 1 to 1 because it fails the horizontal line test. So it's not 1 to 1. B is 1 to 1 because it passes the horizontal line test. So no matter where you draw a horizontal line, it'll only touch the graph once. So 25 is asking if the function is even, odd, or neither. Remember, the constants have an x, what do you call it, variable to the 0 power. And then here the x is first power. So since you have a mixture of powers, even and odd, then this one is neither. If both powers were even, it would be even. If both powers were odd, it would be odd. But since this has a mixed, different parity, 1 and 0, it's neither. Alright, so for 26, they're asking you for the composition of g of f of x. And so remember, this is the inside function. This is the outside function. So this is going to substitute this x right here. So notice that we come in with the inside function, right? So we come in with all real numbers. So let's go ahead and do the algebraic manipulation of g of f of x. So negative 1 over this. And in the blank, in the parentheses, we put in f of x. And then we simplify. So that's negative 1 over x squared minus 2x plus 1. Don't forget about the 1 out here, minus 1. So then that gives me negative 1 over x squared minus 2x. Because this 1 minus 1 is 0. So what, and then for part B, they want you to find the domain of g of f of x. So you factor this into x times x minus 2. So then it's all x such that x cannot equal 0 and 2. Okay? This up here is useless because they didn't ask you for f of g of x. Had they asked you for f of g of x, then we would take this into account because this would be the inside function, so we'd come in with this domain. But since it was the other way around, we didn't really need it. Okay, I just wrote it down so you're aware of it, but we didn't really need it in the problem. Okay, so here's the answer for A, and here's the answer for B, this one right here. Okay, so the function f of x is a piecewise function. It's made up of 3 pieces. The domain for each piece is listed here on the right side, and that's why you see here an open dot. When x is negative 2, I plugged it in here, so negative 2 plus 4 is positive 2. So there's going to be an open dot at negative 2, 2. And then right here, it includes negative 2, so it's going to be a closed dot at negative 2, and y will be 2. And when x is 3, it's open dot right here. Again, y is going to be 2 because it's a constant function. And then down here, it's a closed dot. 3 times 2 is 6. 6 minus 4 is